So in this video, we're going to talk about the effect of a catalyst on the rate of a reaction. Now, I think most of you will remember that a catalyst is a material that is neither a reactant nor a species in a reaction, but it's involved in the reaction, and what it does is it alters the overall rate of the reaction. So typically it's added in order to speed up the rate of a reaction, but how it does that is by lowering the activation energy required for a given reaction. So in the last video, we looked at potential energy diagrams as the reaction proceeds. And so I'm going to just, it doesn't really matter, I'm just using this as an example, but say for an exothermic reaction, you know, the activation energy may be sort of from the top of the hill to the energy of my reactants, right? So that is the amount of energy that you would need in order to start the reaction, make it happen at all. If you add a catalyst to this situation, what the catalyst does, it doesn't change the energy of the reactants or the products. It does not change the enthalpy of the reaction at all. But what it does change is it changes the activation energy. So in other words, this energy hill that needs to be overcome in order for the reaction to proceed is just simply lowered, right? And so we would say that this distance, I'm going to use green again, this distance from my reactants to the top of the smaller blue hill could represent the activation energy for my catalyzed reaction. So I'm going to write that as E subscript C, if you can see that in there. Right, so again, uncatalyzed reactions are going to have a higher activation energy. When I add a catalyst to a particular reaction, then the activation energy required for the reaction to proceed, for reactants to be converted into products, is reduced, okay? That is how a catalyst works. We're going to talk a little bit more about catalysts and different types of catalysts that you might find. So there are two types of catalysts that we might find, two types of catalysis. The first is a homogeneous catalysis. And this is the case where the catalyst is in the same phase or the same state of matter as the reactants. So let's take a look at an example that I have here for you. So for nitrogen dioxide, if we want to convert SO2 to SO3, we use NO2 as a catalyst. And given that, it happens in a couple of steps, okay? So as you may remember, most or many chemical reactions happen in multiple steps to give an overall reaction, and the individual steps are sometimes referred to as elementary steps, okay? So we look at this reaction, and we can see that NO2 is being added to SO2 in order to convert the SO2 to SO3. As a result, we produce NO, and that NO gets used in the next step to produce product. Those are what we call intermediate species. They're neither reactants nor products in the overall reaction, but they sort of appear in the middle. So again, NO in this case is what we call an intermediate species. So maybe we'll just write that in. So intermediate species, and that's because we make it and then we use it in a subsequent step. A catalyst, on the other hand, will look a little bit differently. You'll remember that catalysts are neither reactants nor products in an overall chemical reaction. They are not consumed in the reaction, but they can be involved. So I'm going to let you know that NO2 in this case is our catalyst. Why? I just finished saying that it's not a product or reactant. Well, look at what happens overall. The NO2 is used in the first elementary step, but then I get it back in my second elementary step as a product. So if I look at the overall reaction, the net reaction, it's not going to appear. So let me just write out that net reaction here. So I can see that my NOs will cancel, and my NO2s will cancel. And then so that will give me my SO2, my overall reaction, plus 1/2 O2 goes to make SO3. Okay, so again, just to recap real quick, right? An intermediate species is produced and then used, whereas a catalyst is used and then reproduced so that it can be recycled over and over and over again. So the second type of catalysis that you may encounter is heterogeneous catalysis. So hetero meaning different. So this is when the catalyst is in a different phase of matter relative to the other reactants. So let's take a look at this overall. I mean, unfortunately, this is supposed to be, an animation, but doesn't quite work that well in this platform. So let's take a look at this. So often the reactants are in the gas phase, but the catalyst is in the solid phase. And so what you will see happening is the reactant, so the green molecule and the yellow molecule, the green molecule lands, the catalyst almost acts like a landing dock and for the green molecule, and in some way gives these reactants the activation energy that they require for bonds to be broken and reformed. So green molecule lands on this landing dock of a catalyst, and then yellow molecule lands on. Bonds between the green molecule's atoms and the yellow molecule's atoms break apart and then reform with each other. And when that happens, then the products are free to leave. Okay, so the process by which the process of that green molecule landing on the surface of the catalyst is called adsorption, not absorption, but adsorption. Okay, and then we see the reaction happening itself where bonds are broken and reforming. And then desorption is that process by which the molecules, the new products, are just released from the surface of the catalyst. So one thing you can talk to your parents about, maybe they're aware of a component in your vehicle that uses a heterogeneous catalyst, and that is your catalytic converter. Now often your catalytic converter is like palladium or rhodium metal, and its job is to take all those nasty products of combustion that pollute our air and to convert them into less harmful substances. I've written harmful substances here, but I'm thinking now maybe that should be less harmful because one of the products is going to be carbon dioxide, which we know is problematic. So here are a few questions that I'd like you to try on the topic of collision theory and catalysis. There's a YouTube video here that I'm going to provide we're going to actually watch that in class as a bit of a recap. But I hope that this accomplishes what we hope it will today and that we can move forward with our lesson on rate laws in the next lesson.